think. It can go either way. It depends on whether someone can give you an array of 0 elements, in other words, an empty box. It doesn't make any sense, but it can happen. Okay, sometimes you can end up with an empty box where the size of the array is 0. Okay, and because it is always better to put a pre-checking loop, I'll just do it using a pre-checking loop, which is saying while I is less than bar a bar, do this whole thing, and while. Now, if you know that this is a pre-checking loop and this is how we use I, we have to do some initializations here, don't we? What should I be initialized to? Remember what I said a little bit earlier? Because of this line here, which refers to a bracket I minus 1, it means that I cannot start with 0. Because if I started with 0, then I minus 1 would be negative 1, and we don't want to access element at negative 1 because it does not exist. So we know that I has to start with 1. If I start with 1, then I better make sure a bracket 0 is also initialized to something. What should it be initialized to? It should be initialized to 2, and that's revision 11. I think revision 11 is complete and it is correct, but it is dumb. But it is dumb. Why is it dumb? Remember what we are doing here? We're trying to initialize an array and fill it up with prime numbers. What do you think would be an application of such a table? To help us find the factors of a number and stuff like that, right? But yet, we are not relying on the table itself when we try to determine whether a bracket I has a prime factor other than itself. Are you guys seeing the problem here? In order to determine whether 13 is a prime number, we are still going to try 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on.
13?
Hmm?
We're not going to just do the square root?
Well, okay, we're doing the square root, but we'll still test the composite numbers. Okay, so that's kind of dumb because I already have part of this array filled up by the time I get here. I should utilize that, don't I? Yeah. Okay, so how am I going to utilize that? So this is going to be revision 12. So revision 12 is not making the program complete. It is more like making the program more efficient.
Assign the value of f to the value of the previous index in the array.
Okay. Well, we know that it has to do with f, right?
Right.
Because f is the potential factor, right? And here we are starting with 2, and then it will go from 2 to 3, 3 to 4, 4 to 5, and so on. We don't want it that way. We want it to go from 2 to 3, 3 to 5, 5 to 7, 7 to 11, 11 to 13. So that means instead of using f as a potential factor, we need to keep track of an array index back into the array that we are actually still initializing. Okay? So that means I want this to be an index. Okay, so I'll use fi for factor index. We will start with 0, which is the first element in the array that we are dealing with. Every time we refer to f, we have to say, replace it with a bracket fi. And here again, a bracket fi, a bracket fi. And what about here? Do we increment a bracket fi also, or do we just increment fi itself? We increment fi because we're incrementing the index. We're not incrementing the numbers that we have already found. So now we are dealing with fi and fi. And here we have what? A bracket fi, a bracket fi. We just want to make sure there's no f left. Okay, there's no variable f left in this algorithm. And that's it. This is the algorithm to fill up an array with prime numbers and do it as efficiently as possible. Because in this case, to determine whether, let's say 61 is a prime number or not, it will only have to try 2, 3, 5, 7, and next one up is 11. Okay? Because by the time we get to 11, 11 times 11 is already 121, which is more than 61, and this code will exit at the right time, and it will conclude that 61 is a prime number. Okay. Are there any questions about this algorithm? It sounds like a very good homework assignment to me. Yeah, let's trace it with an array size of 20, right? 20 is going to be a little bit extreme, but I think 5 is not bad. Or I can even give you a top part of a trace. You just have to continue at a certain point. That would be good, I think. Because I give you a part of a trace, with certain parts of it already done, and you just have to take up from that point and continue with the algorithm. So my code, the trace that I give you, can be done at the middle right here. I give you all the states, all the variable values at that time. You just go from there and tell me what's going to happen after that. That would make a very good homework assignment. Sorry?
I was saying that loop's going to repeat so many times on the trace.
No, I can give you, remember what I said? I can give you a partially done trace already. So I could be right in the middle of the innermost loop, which is about done, which is already in the intermediate loop, which is about done, which is in the outer loop, which is about done. So you guys just have to finish it up. I think that's a great homework assignment.
Extra point credit for people who do it from the start.
Okay, so I will give you guys a new homework assignment based on this. I'm going to write it up and post it online. I will send an email to the whole class when it's done. Yes, definitely. Otherwise, I have to watch my own video clip to know what I have done so far.